Hello everybody, a very good morning to all of you. In the last lecture, we discussed capacity of a parallel plate capacitor, spherical capacitor and cylindrical capacitor. Today, we will start with the topic energy of a charged conductor or capacitor. Energy of a charged conductor or capacitor. You know, when a conductor is charged, it develops electric potential. When charged further, charge is to brought against electric potential due to the previous charge. So, work is done in bringing further charge against the potential. Therefore, work is done and energy is spent in charging a conductor or a capacitor. This work is stored in the conductor in the form of its potential energy. The potential energy of a charged conductor or capacitor is equal to the work done in charging it from zero charge state or zero potential state. Suppose a conductor or a capacitor has capacity C. Let a charge Q raises its potential by V. Then suppose it is given further charge dq, if dW is the small work done, in bringing charge dq against potential V, then V is equal to Q upon C. Basic definition of capacity. Suppose it is given further charge dq. If dW is the work done in bringing charge dq against potential V, then dW will be equal to V into dq. The small work done in bringing the charge dq against already existing charge will be equal to V into dq. Or it is equal to, now V is equal to Q upon C, so it will be equal to Q dq upon C. If W is the total work done in giving total charge Q from zero charge state, then W will be equal to integral between limits 0 to Q, Q dq by C, or it is equal to 1 upon C common integral of Q dq Q square by 2, and between limits 0 to Q, so it will be again Q square by 2C. So this will be the work done in charging a conductor or capacitor from its zero charge state to the maximum charge state Q, and it is equal to Q square by 2C. Therefore, energy of the charged conductor or capacitor E will be equal to Q square by 2C, because this work done will be stored as the potential energy of the conductor or capacitor. So E is equal to Q square by 2C. So this is equation number, say this is equation number 2, and this is equation number 3. Now from this equation, V is equal to Q upon C, so Q is equal to CV. We also know that Q is equal to CV. Put this value of Q in this equation, you will be having E will be equal to 1 by 2 CV square. This is another form of energy stored in the conductor or capacitor. So what we did, we just put the value of Q here, Q is equal to CV, so it will be equal to E will be equal to 1 by 2 CV square. Another form will be Q is equal to CV is equal to 2 CV square, or C is equal to Q upon V. Just put the value. C is equal to Q upon V. We also know that. So put this value here. E will be equal to Q square upon V square Q square is equal to Q square by 2C. So just put the value of C is equal to Q upon V here. So it will be equal to Q square by 2 into Q into V. So it will be equal to 1 by 2 Q V. This is the another form of expression for the energy stored in the conductor or capacitor. So this energy will be stored as the potential energy of the capacitor. So when you give a charge to a conductor, potential is developed, and when you have to bring more charge, you have to do work against the already existing charge on the conductor or capacitor, and that work is stored in the form of potential energy and given by the expression. First one is E is equal to Q square by 2C, then E is equal to 1 by 2 CV square, or E is equal to 1 by 2 QV. We just put the value of first Q, V and C, and we got 3 expressions. Next is parallel combination of capacitors. Parallel combination of capacitors. C1, C2, C3. So, this is the parallel combination of capacitors. We are having 3 capacitors C1, C2, C3 and they are connected parallel to each other and a potential V is applied. Then Q is equal to charge, total charge will be equal to Q1 plus Q2 plus Q3. Total charge on the conductors of the capacitors will be Q will be equal to Q1 plus Q2 plus Q3. If Cp is the total capacity of the combination, then Cp will, then Q will be equal to here, Q will be equal to Cp into V, as Cp is equal to Q upon V, so Q will be equal to Cp into V. Therefore, Cp into V, this Q will be equal to Q1. Q1 is C1V plus Q2, C2 into V plus Q3, C3 into V, or Cp will be equal to C1 plus C2 plus C3. Suppose you are having n capacitors of capacity, each of capacity C, then this Cp will be equal to n into C. So, capacity increases in parallel combination. So, capacity increases in parallel combination. So, similarly, सीरीज कॉम्बिनेशन ऑफ कैपेसिटर्स, एक बार फिर से देखें, ये C1, C2, C3 3 कैपेसिटर्स हैं जिनको हमने पैरेलल में जोड़ा हुआ है और इसके साथ एक V वोल्ट की बैटरी कनेक्टेड है. तो जो चार्ज होगा, जो कैपेसिटर की प्लेट होगी C1 की, उसमें प्लस Q1 माइनस Q1 ऑन बोथ द प्लेट्स, और जो C2 पे है वो है प्लस Q2 माइनस Q2, और जो C3 है उस पे है प्लस Q3 माइनस Q3 ऑन बोथ द प्लेट्स. So total charge of the combination will be equal to Q, here Q will be equal to Q1 plus Q2 plus Q3. We know that capacity is equal to C is equal to Q upon V, तो यहाँ से Q will be equal to CV. If Cp is the capacity of the total combination, then this total charge Q will be equal to Cp into V. So put the value of this Q1, Q2, Q3 further, you will be having Cp into V will be equal to C1V plus C2V plus C3V. V cancels out, so Cp will be equal to C1 plus C2 plus C3. If we are having n capacitors, each of capacity C, then this Cp will be equal to C plus C plus C plus so on up to n. So it will be equal to Nc. So Cp will be equal to Nc. So capacity increases in parallel combination. Next is series combination of capacitors. Series combination of capacitors. So this is your series combination of capacitor. The capacitors are said to be connected in series if the last end of the first capacitor is connected to the first end of the second conductor of the capacitor, then its second end of the second capacitor is connected to the first end of the third capacitor is the conductor, and finally the end points are connected to the supply of V volts. Now potential across the capacitor C1 is V1, potential across the capacitor C2 is V2, and potential across the capacitor C3 is V3. So total potential of the combination will be equal to, B will be equal to V1 plus V2 plus V3. If CS is the capacity of the series combination, then this CS will be equal to Q upon V, or V will be equal to Q upon CS. So putting the value of this in this equation, say this is equation number 1, and let this be for remembering purpose, it will be 2, 1 Q upon CS will be equal to Q upon C1 plus Q upon C2 plus Q upon C3, or 1 upon CS will be equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So you can say the capacity decreases in series combination if we are having n capacitors, each of capacity C. In that case, 1 upon CS will be equal to 1 upon C plus 1 upon C plus 1 upon C, and so on, or it will be equal to n by C. So capacity decreases in series combination. एक बार फिर से देखें, we are having 3 capacitors C1, C2, C3, and they are connected end to end as shown, and a potential of V volt is applied to them. Then potential across the capacitor C1 is V1, potential across the capacitor C2 is V2, and potential across the capacitor C3 is V3. Now by total potential of the combination will be equal to V1 plus V2 plus V3. So by the basic formula of capacity, if CS is the total capacity of the combination, then this CS will be equal to Q upon V, and Q is equal to, putting this value of this in this expression, V will be equal to Q upon CS. So Q upon CS will be equal to, V1 will be equal to Q upon C1, V2 Q by C2, and V3 Q by C3. So finally 1 upon CS will be equal to Q, taking common, it will cancel out. So 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. If we are having n capacitors, each of capacity C, then this 1 upon CS will be equal to this, and finally it is equal to n by C. So capacity 1 upon CS is equal to n by C. So CS will be equal to C by n. So capacity decreases in series combination. Remember, in case of resistance, it is just reverse. Resistance के केस में क्या होता है? If you join resistance in parallel, the total resistance decreases. Whereas in case of capacitors, if you join capacitors in parallel, the capacity increases. In parallel combination of resistance means lesser resistance ultimate, and parallel combination of capacitors means increase of capacity. Whereas in series combination of resistances, the resistance increases, whereas in case of capacitors, if you join them in series, the capacity decreases, just opposite to each other. So this completes your second unit, and few numericals regarding this chapter. I think please go through it. I will discuss 1-2 numericals here and then remaining in our interaction class also. First numerical, a spherical capacitor consists of two spheres of radii 10 centimeter and 12 centimeter with a dielectric constant K equal to 6 between them. Calculate the capacity. A spherical capacitor consisting of two spheres of radii 10 centimeter and 12 centimeter respectively with a dielectric K equal to 6 between them. Calculate the capacity of the capacitor. So this you can do, just apply the formula of capacity of a spherical capacitor is given by C is equal to 4 pi epsilon naught into K R1 R2 over R2 minus R1. So capacity will be equal to 4 pi K times epsilon naught into R2 R1 over R2 minus R1. Using this formula, you can find the capacity of the spherical capacitor. So just solve at your own. You know the value of epsilon naught, you know the value of radius R1, R2. You have to consider these radii in SI system, that is meters. Then finally the capacity will come out to be in farads. कर सकते हैं आप, और अगर नहीं हुआ तो इसको हम फिर डिस्कस करेंगे अपनी इंटरेक्शन क्लास में. दूसरा क्वेश्चन है वो भी इसी तरीके से है, फाइंड द लेंथ ऑफ पेपर यूज्ड find the length of paper used in a capacitor of capacitance, in a capacitor of capacitance two microfarad if the dielectric constant of paper is 2.5, if the dielectric constant of the paper is 2.5 and its width and thickness are are 50 millimeter and 0.05 millimeter respectively. So our question is, find the length of paper used in a capacitor of capacitance 2 microfarad if the dielectric constant of the paper is 2.5 and its width and thickness are 50 millimeter and 0.05 millimeter respectively. तो ये है आपका पैरेलल प्लेट कैपेसिटर. तो इस केस में क्या है, कैपेसिटी ऑफ ए पैरेलल प्लेट कैपेसिटर इज गिवन बाय C is equal to epsilon naught into epsilon r into A upon D. ये आपका बेसिक फार्मूला है जिसको यूज करते हुए आप कैपेसिटी ऑफ ए पैरेलल प्लेट कैपेसिटर निकालेंगे. आपको विड्थ एंड थिकनेस दी हुई है, यहाँ से आप एरिया निकाल लेंगे हमें, और निकालना क्या है हमें, फाइंड दी लेंथ निकालनी है. लेंथ एरिया क्या होता है आपका, लेंथ इनटू ब्रेड्थ. तो यहाँ से आप 50 मिलीमीटर जो है थिकनेस दी हुई है और विड्थ दी हुई है, 50 मिलीमीटर इज विड्थ और थिकनेस दी हुई है 0.05. तो वहाँ से जो आपका A हो जाएगा, यहाँ से A विल बी इक्वल टू CD अपॉन एप्सिलम नॉट इंटू एप्सिलम R. ये जो 0.05 है ये आपकी थिकनेस है, जो क्या है, इट्स विड्थ एंड थिकनेस आर, हाँ विड्थ का मतलब है आपकी चौड़ाई, जो D विल बी इक्वल टू हियर 0.05, D will be equal to 0.005 millimeter. So L into B, length into breadth will be equal to area. So you are given breadth which is 50 millimeter. So just put the value of breadth here, and then finally you can, by putting the value of other quantities, this you can find the length of the paper. So length of the paper will be equal to, L will be equal to, from this expression एरिया की वैल्यू आप पुट करेंगे तो ये विल हो जाएगा आपका C इंटू डी अपॉन एप्सिलम नॉट इंटू एप्सिलम आर. सो इट विल बी इक्वल टू, L विल बी इक्वल टू C इंटू डी ओवर breadth B into epsilon naught into epsilon r. So in this way you can find the length of the paper used in a capacitor of capacitance 2 microfarad. So C is 2 microfarad, thickness is 0.05 millimeter, and epsilon naught and epsilon R value is 2.5, and this epsilon naught is having a standard value 8.85 10 to the power minus 12. So by putting these values in this expression, you can find the capacity of the, you can find the length of the paper used in a capacitor of capacitance 2 microfarad. कर लेंगे? I think you can do it. Okay. This was question number 2. Now, third question. Third question is, a cable consisting of a wire of 3 millimeter in diameter, 3 millimeter in diameter, and insulated with 3 millimeter thick, insulated with 3 millimeter thick dielectric of relative permittivity 4.5 with a dielectric with a relative permittivity 4.5 is placed in water, Calculate the capacitance of 2 kilometer of wire, 2 kilometer of wire. 2 kilometer of wire, that is the length of the cable. 2 kilometer length of the cable. So this is third case, the capacity of a cylindrical capacitor. The formula is, the capacity of a cylindrical capacitor is given by the formula C is equal to 2 pi epsilon naught into epsilon R L upon 2.303 log of RB upon RA. C is equal to 2 pi epsilon naught into epsilon R into L over 2.303 log of RB upon RA, where RB is greater than RA, outer radius and inner radius. तो यहाँ से सबसे पहले जो आपने रेडियस निकालना है, ये क्या है, 3 फिल्म, ए केबल कंसिस्टिंग ऑफ वायर ऑफ 3 मिलीमीटर इन डायामीटर। तो इसका क्या मतलब हुआ कि जो वायर का रेडियस कितना होगा, इंटरनल रेडियस, इट विल बी 1.5 मिलीमीटर। अब इसके ऊपर 3 मिलीमीटर थिकनेस की जो है वो डाइलेक्ट्रिक चढ़ा हुआ है, तो उसके का ये होगा आपका RA विल बी इक्वल टू 1.5 मिलीमीटर एंड RB विल बी इक्वल टू 3 प्लस 1.5 millimeter, that is 4.5 millimeter. So RB will be this one and RA will be this. Other thing you know, length आपको दी हुई है 2 kilometer, 2 into 10 power 3 meters. Accordingly, put the value of this epsilon r is again 4.5. Other thing you know, just put the value and get the result. जो इसमें सिर्फ आपको ये रेडियस कैसे निकालने हैं वो पता होना चाहिए. डायमीटर दिया हुआ है तो इसका रेडियस हो जाएगा आपका 1.5 इनर रेडियस, और इसके ऊपर 3 मिलीमीटर थिकनेस की जो परत चढ़ी हुई है वो इसके ऊपर ऐड हो जाएगी. तो 3 plus 1.5 will be equal to 4.5. So in this way you can solve this numerical. Okay, one more numerical regarding this chapter, the last one. Find the capacity of the following combination of capacitors. ये हमारे पास कोई कैपेसिटर्स हैं, and these are the end points of this combination of capacitors. Suppose this is A, this is B, and each capacitor is of capacity 2 microfarad. 2 microfarad. ओके, तो इसको इस कैपेसिटी को निकालने के लिए सबसे पहले क्या करते हैं हम, वी मार्क द कैपेसिटर एज, सपोज दिस इज C1, this is C2, this is C3, this is C4, this is C5 and this is C6. तो टोटल कैपेसिटर हमारे कितने हो गए, 6. अब देखिए हम जब इसको सॉल्व करेंगे, जो छोटे छोटे सर्किट है अंदर वाले पहले उनको सॉल्व करेंगे और उनको सॉल्व करते हुए आगे बढ़ते जाएंगे. जैसे पहले ये जो कैपेसिटी है वो हमने C1, 2, 3, ये जो 3 कैपेसिटर है C1, C2, C3, इनकी कैपेसिटी निकालेंगे. तो कैसे निकालेंगे, ये क्या है आपका, क्या है, सीरीज कॉम्बिनेशन. तो सीरीज कॉम्बिनेशन में क्या होता है, कैपेसिटी 1 अपॉन सीरीज में 1 अपॉन C1, 2, 3 विल बी इक्वल टू 1 अपॉन C1 प्लस 1 अपॉन C2 प्लस 1 अपॉन C3. So it will be equal to 1 by 2 plus 1 by 2 plus 1 by 2. So this will come out to be 3 by 2. अब C1, 2, 3 कितना हो जाएगा, ये तो आया आपका 1 upon C1, 2, 3. So C1, 2, 3 capacity of these capacitors will be equal to, यदि 3 by 2 थी तो जवाब हो जाएगी 2 by 3. ओके, तो अब ये आपका जो सर्किट है ये ऐसे ही. अब ये दूसरा जो है आपका कौन सा, 4, 5, 6, C4, 5, 6 निकाल लें. C4, 5, 6 will be equal to, it is again a series combination. इसी तरीके से you will get the capacity of this combination also as this 2 by 3, क्योंकि similar है. तो now this circuit reduces to, क्या हो जाएगा, अब ये एक कैपेसिटर ये बन गया और एक ये बन गया. A, B. अब इसकी कैपेसिटी आपकी कितनी है 2/3 और इसकी कितनी है, इसकी भी 2/3. नाउ दिस इज ए पैरेलल कॉम्बिनेशन ऑफ कैपेसिटर्स. तो पैरेलल में क्या होता है, तो अगर हम सभी, अब ये क्या था आपका C123 और ये था आपका C456. तो टोटल कैपेसिटी ऑफ कॉम्बिनेशन सभी की इफ इट इज C देन इट विल बी इक्वल टू, पैरेलल कॉम्बिनेशन में क्या होता है C1 अगर C123 प्लस C456, so it will be equal to 2/3 plus 2/3. कितना हो गया 4/3. It is a parallel combination. So total capacity of this combination will be equal to 4/3 microfarad. This is also microfarad. Remember, units are important. So this capacity of this combination is 4/3 microfarad. ऐसे ही आप और कोई क्वेश्चन ले सकते हैं इसी तरीके का, जिसमें कैपेसिटी कैन वेरी, इट कैन बी 5 माइक्रोफैरड, 2 माइक्रोफैरड, 3 माइक्रोफैरड एंड सो ऑन. लेकिन बेसिक तरीका जो सॉल्व करने का है वो यही है कि सबसे जो छोटे वाले कैपेसिटर सर्किट हैं उनको धीरे धीरे कैपेसिटी निकालते जाइए और इस सर्किट को सिंपलीफाई करते जाइए एंड फाइनली you reach to the combination which will be either parallel or series, and by applying series law or parallel law you can find the capacity of the whole combination. तो ये सीरीज में थे पहले, ये भी सीरीज में थे. तो ये आपकी सीरीज में क्या होता है 1/C is equal to 1/C1 plus 1/C2 plus 1/C3. आपने ये कैपेसिटी निकाल ली, तो टोटल कैपेसिटी C123 will be just इनवर्स ऑफ इट दैट इज 2/3. और ऐसे ही ये भी सेम ही है, तो इसका भी जो आएगा वैल्यू आएगी वो भी 2/3 आएगी. तो दिस सर्किट रिड्यूसेस टू दिस एंड फाइनली इट इज ए पैरेलल सर्किट. इन पैरेलल सर्किट क्या होता है Cp इज इक्वल टू C1 प्लस C2. तो यहाँ से आपने 2/3 प्लस 2/3 which is equal to 4/3. So capacity of the whole combination of a capacitor is 4/3 microfarad. So this completes your third unit, and next unit is batteries, which we will start on next lecture. Note your DHA for today. Drive an expression derive an expression for the capacity of a derive an expression for the energy stored, not energy stored, for the energy stored in a capacitor also derive an expression for the capacitors in parallel and series combination. This is your DHA after CT1, fourth DHA, or whatever the number, previous number I think it was 11, it may be 12th in regularity. Fourth after CT1 and overall number is 12th. So that's all for today. ये सेक्शन ऑटो सेक्शन, सिविल सेक्शन और मैकेनिकल सेक्शन को लिंक भेजे गए हैं, वो जो उनको इन्विटेशन दिया गया है वो इनरोल हो जाएं, और अगर किसी को इन्विटेशन नहीं मिला है तो वो आज शाम तक मिल जाएगा। तो ये जो तीनों ब्रांचेस हैं, ऑटो, सिविल एंड मैकेनिकल, जितने भी इसके स्टूडेंट्स हैं टेक्निकल कॉलेज के, वो सभी इसमें इन्विटेशन में अपनी क्लासरूम में ज्वाइन कर लें।